And
alrighty. Well, how about we get started and I say hello to the internet. Welcome to Open Source Directions, hosted by OpenTeams. They're the first business-to-business marketplace for open source software services. Open Source Directions is a webinar that brings you all the news about the future of your open source projects. I'm Tony Fast. I'm a data scientist at Quantsite, and I'm a community organizer in Atlanta, Georgia. I'm super excited to be hosting because I finally achieved my master plan. I was on episode 1 as co-host, and now look at here I am. I'm running the show. David, I've overtaken you, but I really want to welcome David, my co-host now. How the tables have turned.
Hi, I'm David Charbonneau. I'm CTO at OpenTeams. I'm also a senior architect at Quantsite, and I'm based in Durham, North Carolina. And it's our great pleasure to introduce Thomas as our guest today.
Hi, everyone. I'm Thomas Wiecki. I work on the PyMC project, which I'll be talking about a lot. I'm currently involved in something related to that, but I feel I want to build up the suspense towards that a little bit more, so there will be the reveal of what I'm scheming next. So stay tuned for that. But before that, I've been studying neuroscience at Brown, and then decided that academia wasn't the right long-term trajectory for me, and then worked at Quantopian as the VP of data science there for 8 years, and now doing different things related to PyMC. So thanks everyone for tuning in. I'm excited to be here.
Well, thank you for being here with us. I'm super excited to talk about all of your experience and work in PyMC. But before we get to all of those details, we kind of like to start these episodes off just getting a feel for what y'all are finding interesting going on. And it looks like this week we're looking at what your favorite most recent PR is, which is basically only a thing you can say in open source directions. So Thomas, I was wondering, do you have a favorite PR this week?
Boy, do I have a favorite PR. Yeah, should I show it to you guys?
Sure, if you want to, that would be great.
Yeah. Let me set this up. Here we go. So, unsurprisingly, it's a pull request to the PyMC3 repo, and it's from Greg Mingus, who I've never heard before. And he says, well, I'm adding this MLDA stepper, and well, I have no idea what that is either, but apparently it's this really cool new Metropolis Hastings algorithm that they researched and then are publishing here. That they published and then are now adding to this library. So he's a first-time contributor, and so he describes the performance implications, what he did to do it, the references, the papers, other people are excited about it. And then there's a lot of discussion actually going into this, but he's just really responsive to all the feedback, adding documentation, revising the pull request. Just looking at the code is also pretty massive. It's from the Alan Turing Institute. So he's adding it to the docs, writing tests. There's all the nice things that we're looking for in a pull request. And what I really also like about this is not only the quality of the pull request, which is super high, the responsiveness of the author, but also the fact that we are able to attract the researchers that are writing papers on these samplers, and then are basically saying, well, we could just put up a reference implementation, but instead they're saying, well, more people use it if we add it to this library, which already has all the probability distributions and inference engines, and now it has one more sampler, and so they're just directly adding that. And that is, for us, the best thing that could happen, right, is people, we don't have to implement those, or some other people who really want to use this have to implement this, but just the researcher directly goes and implements this for us. So I was really excited about that. It's about to get merged and will be part of the upcoming release. It's very briefly, it's a sampler where we have a model that has different modes of approximation. Like you have a model that is a very rough approximation because you may be evaluated over a very rough grid, and you have a very fine-tuned model that is more costly to estimate. You can use the rough approximation, the coarse model, and the fine-grained model together, and basically use the rough model, course model to evaluate it, to find a good proposal, and then evaluate on the other one. So you can just, the cheap evaluations you're doing on the course model, and then you're only asking the precise model, which is costly to estimate, for that final accept or reject step. So really cool, and a great example of open source coming together.
Well, this seems like what preprint should be, and pre-publication should be. I love seeing this, and it's super cool that y'all provide a safe space for this stuff to happen too. So thank you for sharing that. David, how about you? Have there been any PRs that have really caught your eye this week?
Actually, yeah, but primarily because I'm neck deep in the project. So for OpenTeams, we've been building a new kind of infrastructure so we can build up REST endpoints and clients for those REST endpoints really, really quickly. I can share my screen as well real quick and kind of show off the project. So we call it SCRUD. And we call it SCRUD for semantic create, update, and retrieve, update, and delete. I'm trying to find the right window. Here it is. So if you looked on GitHub and you went to OpenTeams Inc., we've got a couple of different projects that I can share, and we're pushing on all 4 of these are really, really fast. So we've got this overall SCRUD strategy that we've defined, where what we're trying to basically do is make it so we can just specify a JSON schema and some JSON LD context and get endpoints for free, but then go further and building on the work folks have done around JSON schema form generation to make it so we can really rapidly throw together applications, but applications that are informed by the meaning of the data, not just the type of the data. So a great example is if it's a location field, then maybe we want to provide you like a map selector or something. And so this provides a way to kind of flexibly extend how things get rendered according to their meaning. The goal being we should be able to build up things really, really fast by defining these mappings and do less coding. So we've been building up the front end of this, which includes a kind of special caching client and an extension or wrapper around the view schema form generator. And then we've had another group of folks working on the back end, making it so that if we start with these schemas and these context documents, we get endpoints for free. So we're going to be demoing this internally tomorrow, and I'm really proud of the team and really, really excited. Super
cool. Well, hopefully you can get ProbOnto in there, the ontology for probability distributions.
Ooh, that'd be cool.
We can have probabilistic UI, right? Just rendering sliders and integers just randomly based on distribution. But yeah, let's get to all of the statistics and probability distributions that we can handle now. I'm going to move along on my PR part, and I really wanted to dig into the PyMC project here. There's a lot of interesting stuff. There's a lot of interesting open source drama, organizational things happening on the Jupyter Team Compass right now. It's my afternoon soap opera, so that's why I like those PRs. They're a little juicy to me. But nevertheless, PyMC here. PyMC is a project. It's on GitHub, of course. And there's over 5,000 stars on the project. So it's pretty active. Quite a few forks on there also. And it looks like on Conda Forge, for example, there's over 200,000 downloads. So PyMC seems like a really popular project, and I'm excited to talk about it here. So David, maybe you could lead us off.
Yeah, absolutely. Thomas, can you tell us a bit about who started PyMC and why was it started and what need does it fill?
So Chris Fonnesbeck.
Oh, you're on mute, Thomas.
I am?
It was just delayed.
Oh, okay, good stuff. Yeah, so PyMC 1 was launched by Chris Fonnesbeck while he was still in grad school many moons ago. And so he basically just wrote this together in pure Python as just to fill his own needs. He needed a sampler to run his biological models. And then, however, just because it was pure Python, it was pretty slow. So he teamed up with David Huart, and they then created PyMC 2.0. And that was a major improvement because now the likelihoods were implemented in Fortran code. made it run vastly faster than the previous version. And that gained quite some popularity, and that's the level where I got involved in it, and I built some packages on top of that, and that's how I got to meet Chris and some other people who were involved in the project at that time, like John Salvatier. And John was really thinking ahead back then about how can we push these frameworks to really the next level. And he became really interested in these gradient-based samplers. And so that requires you not only to evaluate the log likelihood of the model, which is what PyMC 1 and 2 and like every other framework can do, you also need to compute the derivative, the gradient of that. And that turned out to be really difficult. So he tried doing that, but it didn't quite work. And then, but he knew that those samplers were just vastly superior to everything that came before. And he was really the first person to realize that these deep learning frameworks, back then they only existed Theano, now we have TensorFlow and Pyro and all PyTorch, all these other ones. But he was really the first person to be like, well, I wonder if this tool that was built for building neural networks and can compute gradients via auditive can be retrofitted to build computational graphs of statistical models. And turned out that was not quite possible, but almost possible. So I did like the legwork to do that, and then really wrote the core of PyMC 3 based on Theano. And just like now this is obvious, right? Like we have TensorFlow probability, we have all these other packages that are building on these computational graph libraries. But back then, no one had even thought about it. So for me, there was really just like incredible foresight on his part to do that, and then also to like really write the core of PyMC 3. A lot of that still exists today. And I remember talking to him a lot about this and being extremely excited because I was like, this is the coolest thing ever. And I contributed a few small pieces, and then so he built this prototype, but then sort of moved on to greener pastures. But I was just so excited about it that with correspondence back, basically we pushed that over the finish line and turned this into like a proper 3.0 release that people could use. And back then it was still pretty small, but so slowly we started getting more contributors and more users, and just very organically grew over the last couple of years to now where we have over 20 core contributors, and you name some stats of downloads. So we have a lot of users in academia. There's over 700 citations to our original publication, and it's being used at all the big and small companies. So every day we're learning about new companies that are using PyMC 3. So that is really motivating and inspiring to us. And really, the reason why we develop this is, well, we all just believe that Bayesian statistics is the best way of doing statistics. That's what I would say. To me, it's the first time that statistics, which I had many classes on, but for me, that was the first time where it really actually made sense. We're like, oh, I don't have to like derive all these different estimators for the student t-test and whatnot. I just can write down my model, and then I like hit the inference button and it works, and I can change the model, like, and it's all laid out there in code. Like, this is incredible. And so for me and all other data scientists, it's just really empowering to be able to build my own statistical models and get uncertainty quantification and all these very nice things, be able to include my expert information or get that from the stakeholders who are interested in the model and have their own opinions on what sort of should go on, so I can incorporate that into the model too, and solve very targeted problems on very richly structured data set problems. So contrast that with machine learning, for example, where, well, the problems that you're solving there is you have a table of rows are the data points, and then you have a bunch of features, and then you have labels, or it's a regression type of problem, and you just, if that is your problem, right, and you only care about prediction, amazing. Just go ahead, train XGBoost or scikit-learn, like, it's amazing. But if your problem falls outside of that domain, it becomes really difficult, right? You have hierarchical nested structure in your data, or it's time series, like all of these kind of things are just really common problems, right? And they're often not very well suited by machine learning, which is taking up so much attention. But I think more and more these methods are being realized as just very elegant and powerful methods to solve these problems. And
Yeah.
and with these new samplers, we can finally actually do that.
So that was great. I love all the history, and it's deep. But let's ease into it a little bit. I'm just curious about the name. Clearly, all of that history and the name mean something. Can you tell us a little bit of the history of the name and kind of the logo? Just kind of give us some, branding context around the PyMC project.
PyMC just literally stands for Python, and MC for Markov chain Monte Carlo. I think at some point Chris debated calling it MCMC, but that was a bit long in the tooth. So PyMC it was and is. And I don't know who first brought in the rocket ship of the logo, but when we did our logo for PyMC 3 on 99 Designs, we just upload the previous one, and every designer just really latched onto the rocket. And I mean, I think the rocket's kind of cool, right? It's a spaceship. It has been used at SpaceX actually to build rocket ships, so that's fitting.
Awesome.
It's it takes you to the moon.
It looks like a distribution.
I never made that connection, but that's excellent. Yeah, like a normal distribution almost. Perfect.
Well, are there any alternative projects out there that you're aware of?
No, I'm just kidding. Of course. So the other really big, popular, and amazing project is Stan. They are. It's written by Andrew Gellman and a lot of other really smart people. It has come up about the same time as PyMC 3 actually, and they also use these gradient-based samplers, which is the major revolution. And we're really indebted to these guys. They have been really helpful, and a lot of features in PyMC 3 are directly inspired by what the Stan guys have been doing. The reason why I really like PyMC is just you can write your models directly in Python, and for me that's just a more natural way. I don't have to enter the data here and get results out there, and there's this weird wrapper thing going on. Of course, the downside is you can only use it from within Python. So if you're an R user, you can't really use PyMC 3, but you can use Stan. And then since then, there have been a whole bunch of other really cool, interesting packages that I would say are more experimental or targeted at researchers, just because they're more low level and don't really have all the nice UX that I would say PyMC has. And those include Pyro or TensorFlow Probability. Some really cool work is being done there, and they're really pushing the boundaries and pushing it also in the respect to how large scale these models can be.
Very cool. It's great to hear about all those different things. Oh, Tony.
Well, I'm muted accidentally. Oh, yeah. So thanks for that description. Is there something? Can you tell us a little bit about the technology that PyMC is built on and how it kind of differentiates itself from those other tools?
Right. So PyMC is built. PyMC 3 is built on Theano, which was the very first deep learning library that allowed you to write down basically any neural network, and then it would take that, pour that into a computational graph. From that graph structure, you can do all kinds of simplifications. You can compute gradients, and then you can also compile that down to C or to the GPU, and then make it run really fast. For PyMC 3, we're really benefiting from that because the whole code base is just Python, right? PyMC 2 had these Fortran wrappers that made installation really, really difficult. Now it's a pure Python library, and it's fast because, well, we have this compiler in the Theano library that is doing that. Stan has wrote that mostly themselves. The core is written in C++. So they're already basically been taking that and compiling that themselves. So we don't have that burden. And we're getting GPU support for free, which is kind of nice. Since then, all these other packages have really followed in those footsteps of using computational backends. Now Theano is pretty old by now. I still think it's one of the best actually, but nonetheless, people are not as excited about it as they were about TensorFlow or PyTorch or now JAX. So that's what I would say is the technology that we're using.
Oh, who are the current maintainers of the project? The day-to-day keeping it going.
Well, really, it's a lot of people. I'm I don't want to list them all just because I would forget some. And so, as I said, there's over 20 people who are like active on it. So if you just browse GitHub or you look at the commit history, that would like give it much more justice. But yeah, there's a lot of people that have been involved for a really long time, and they're all extremely talented and are really pushing the project forward. So one thing that I'd like to correct is a lot of people think that I'm either the author or like the person who like has done the most work. Neither of these are true. Like it's an effort by a lot of people, and the main author of it is John Salvatier, who like wrote the initial prototype. So credit should go to everyone there.
It sounds like it's a real vibrant and active community. I mean, we love to see that. That's exciting when we get to talk about that.
Well, so clearly statistics apply to a lot of people, or at least I hope they realize that. What communities do your users and your contributors come from? Or is that another thing where you can't list it because you'd skip some people too?
That's exactly right. It's just too many. So one thing that I love to do is just browse the papers that are citing PyMC3. So because like all of those are papers that use it for their science. So a lot of it is astrophysics, biology, seismology, zoology, like just insane, like chemistry. It's really from like domains I haven't even heard about. So there's a toolbox. So it's being used in a lot of papers directly, but there's also toolboxes built on PyMC3. One of those is, for example, Exoplanet, which is a toolbox used to discover stars, like planets outside of our solar system. Just like, that's totally wild. I mean, it's incredible to have that amount of impact, right? And then like all these different domains. There's BEAT, which is like for earthquake detection, and just many more. So yeah, it's really exciting, and it's used in, I haven't found many domains where it's not being used. So that would be easier to list, and also just in companies. So a lot of companies are using it. Surprisingly, a lot of them are using it for simple things like A/B tests. So that seems to be a very popular reason, but also there in finance. So I used it a lot at Quantopian to do portfolio allocation. So that is really just a testament to the versatility of, well, statistics in general. Is you can just use it for whatever data science problem you have. I think for a lot of those, if it's more structured, as I mentioned before, it could be a great fit.
Thanks so much.
Yeah. Let's see. Is the project participating in any diversity and inclusion efforts today?
So yeah, we definitely are very cognizant of that and are talking internally a lot about that. And a lot of our members are active in those communities. So Raveen, for example, is being very active and like presenting that at the PyLadies LA meetups and those types of things. So yeah, we love those initiatives, and where we can, we support them.
That's fantastic. Oh, you're on mute again, Tony?
Yeah, I know. I keep doing it. I got a fan on here.
Step up the game, man.
Yeah, it's a little. I apologize.
That's all right. That's all right.
Working on it. Yeah. So thank you so much for that introduction. I think now it's time to get to the goods, though. Maybe we could shift over to a project demo. So Thomas, if you could kind of get your screen set up and walk us through some things. But in the meantime, I really want to thank our sponsor, Quantsite, the good folks that keep me working in science and day to day. At Quantsite, we're creating value from data, and this is brought to you by Quantsite. We've got a lot of open source stuff going on.
Oh yeah, one thing that I also, in terms of like which domains are using it, this website called rt.live, which is a very timely website for estimating the reproduction factor of COVID-19. So here, for every state in the US, you get an estimate of the reproduction factor, and of course, with Bayesians, we have error bars or uncertainty intervals around this, and you also get a timely estimate for this. So the model was built by Kevin Systrom and Thomas Wiecki. So Kevin Systrom is the co-founder and former CEO of Instagram. So that was a really interesting sort of thing that happened, where he was just like, oh yeah, let me just build this model here. I'm not really an expert, but I'm going to use PyMC3 to to do that, and we helped with some technical support. And so the model is also open source, so you can check it out and really look at the PyMC 3 code that does that. And but yeah, so the model itself is actually really sophisticated and interesting. There's also a tutorial here, and so that is, I think, I would argue, one of the best models out there currently for estimating the reproduction factor.
If you want to show this
So
now,
just-
Buff, you might have to jump to NB Viewer because GitHub's just like sometimes.
Right. What is up with that? Okay, so PyMC 3, let's just like take a brief look. And tell me if I'm going too slow and you want me to speed up. I'm gonna just try and do a high-level demo to give an idea.
Slow is good.
Slow's good. Everybody, the pace of life is far too fast for how little we leave the house.
I couldn't agree. Yeah. Yeah, here is the website, and Colin Carroll did an amazing job with that. So he really just took our previous website, which was sort of a little bit old, and really revamped that. And so yeah, you can see basically this is probably the simplest model. Well, not the simplest, but a simple model that is just a linear regression. And let's say we have some data x, these are my coefficients, and then I have some y's that I want to model, that I want to explain with my linear model. I set up a model context. So this is just boilerplate code and will be for bookkeeping. Every model will look like that. And then we define our parameters. So here we have the weights of my linear regression, and I have a noise parameter, that is the variance, that I'm gonna, or the error term. And here, because we are Bayesians, we don't just define the parameters, we also define priors, place on them. And here for the weights, I'm now choosing a normal prior. So PyMC 3 comes pre-equipped with a lot of the probability distributions that you want to use. So this prior basically says, without having seen any data, what do I believe a likely coefficient for this linear regression to be, right? So I haven't seen any data, but I still might have beliefs about that. So here my belief is that the coefficient is going to be centered around 0 with a standard deviation of 1. And then for the noise, well, I have some prior information, right? I know that the standard deviation of my normal likelihood can only be positive. So that's why I'm choosing a so-called gamma distribution. I'm giving it a name just before I did here. It has 2 parameters, and then we'll just specify the shape of that gamma distribution. And now I'm building this model together and say, okay, I assume that my data is normally distributed. Again, I give it a name, and then my mu, the mean of that data, is now going to be a vector, which is the output of my data x and the dot product with the weights. So basically, this is yeah, just following the math of the linear regression, and then my sigma is the noise parameter. Here with the observed keyword argument, I give it the output data that it's supposed to model, and then this concludes the model specification. And what's happening behind the scenes here is that we're building up this Theano compute graph of log probability, so nothing's actually happening. But now, once we have that model specified, we can do all kinds of things with it and inquire into it. One thing is we might just want to sample from the prior, like what does the model think is, what the prior, what kind of patterns does the model think are plausible? So this is the prior predictive. Then I can also do, and that is mostly what we do, is we sample from the posterior, which is basically what is my belief in my parameters after having seen the data. So this is usually, if you run maximum likelihood estimate, right, you're just fitting the parameters to the model. Now here, of course, we're Bayesians, so we will have not just single numbers as a result, but we have probability distributions, and I will show what that looks like. And then we can also sample from the posterior predictive set. So this is just basically the very core intro of how you can do this model, but really the power of the approach comes by being able to also build much more complex models. So if you click on examples, you see that there's all kinds of different ones. So there's various ones on linear regression models and hierarchical regression, which is a very powerful tool, and also more advanced ones. There's different case studies that you like. For example, this is a very classic hypothesis test that you might want to run. And also more advanced one like Gaussian processes, which are very flexible regression type models, non-parametric ones. There's ordinary differential equations examples, mixture models. So every type of model you might want to build, we have an example of how to do that. So this is really a treasure trove of learning about this. And what I also wanted to show briefly was an example model.
So can I ask you a quick question about this? I mean, I looked at the docs last night. They were gorgeous. And I was like, oh, I learned some things. I was like, oh, what's this distribution? And it was fun to like, kind of poke around there. How does this help you teaching statistics? It seems like you can teach statistics in a much more like rich and visual way than perhaps like the old way.
It's funny you say that. So one thing that I'm doing is building a course that does exactly what you just said. So I think there is a much better way to teach statistics by using intuition and visual graphics first, right? So I think a lot of statistics books and resources are just extremely math heavy, right? So for someone like me coming from software engineering, it was it took quite a while really to like go through all the math and really understand things at an intuitive level. And once I did, I noticed that like, oh, well, this is actually not a complicated concept at all. Like a lot of statistics is actually really simple once you sort of have an intuitive understanding for that. And with this course, which I'm currently creating, I'm basically want to teach statistics in this way. So if you're interested in that, go to twiki.io and enter your email address, and then you'll be updated on my progress on the course. So yeah, I think there's a better way to teach that, and I'm currently working on providing that.
Super cool, thank you.
So one idea that I just wanted to plant, which for me was really when I first grokked the power of Bayesian statistics, was this model where we are looking at the returns of the S&P 500 over time. So these are just daily returns. And one thing that you can clearly see is that volatility, right, how wide these swings are in both directions, really clusters over time. So here in 2009, right, during the financial crash, there was a lot of volatility in the market, then it sort of decayed. And well, we don't plot it until today, but during COVID-19, definitely a lot of volatility as well. So how would we model this? Well, returns we might assume are normally distributed, but that is actually a pretty terrible model just because we're having these wide swings. So you can use a student t-distribution, which has more mass in the tails and accounts for these sort of black swan events or just like much more these tail events. But also what becomes clear is that if we just fit a student t-distribution, right, or we can just think of a normal distribution, that the standard deviation of that distribution will, if we just fix that over time, that'll be a terrible model. So instead what we can do is we can allow that to vary using what is called a Gaussian random walk. So that is a specific type of prior that we can place, and that will allow the standard deviation to change ever so slightly over time. And this is what that model looks like. So we have this Gaussian random walk distribution in here, and then we just feed that into the student t-distribution. And with the power of Bayesian statistics, we can just fit that. We just call the sample function. We don't have to do anything else. We look at the posterior, and then we get the volatility over time and how it's changing. And what I just want to highlight about this is this model is actually crazy complex. So instead of just having one standard deviation parameter and one mean that we're estimating over this data set, now we have a standard deviation parameter for every single data point, right? So we have more parameters than data points here, but it still works because of the constraints we're placing in here. So because we're assuming that this has a Gaussian random walk and that it can't just change willy-nilly at every time point, but will be constrained to a previous point, we can still fit that model. So this is really now, yeah, as I said, quite a complicated model, but with the nut sampler, this works really well, and we can just estimate it easily. So that idea we can just extend to other ones, like let's say we have a linear regression that we want to do, where over time, so this is the price of two stocks over time, and you can see that they are correlated, right? But they're sort of changing over time. We can just apply that same trick. So this is if you just fit a linear regression to it, but we can apply that same trick of the Gaussian random walk and say, okay, my intercepts and my slopes are allowed to change over time according to this random walk. So they're going to be tied and distributed according to the intercept at the previous time point. And again, we're using that Gaussian random walk distribution. I'm well aware that like this is not enough to grok, but I just want to show the high-level idea of this. And then again, we just call the sample function, and we see that the intercept is changing over time, the slope is changing over time, and now with just a very simple change to our original regression model, now we get a regression that is also allowed to change over time. So this is basically now the new model. And so that idea you can just easily extend to all kinds of topics. Like here, I have a blog post also on my blog for doing this with logistic regression. So if we have data that is also changing over time, we can build a logistic regression model that is also using the Gaussian random walk, and then fit a classifier where intercept is changing over time. So that's pretty cool. And then you can also extend that to a neural network model. The data looks like this. So now we can't linearly separate that, right? So this is like the half moons data set and changing over time. We can build a neural network model where the weights are allowed to change over time. And then also basically build a classifier, a nonlinear classifier that is able to separate this non-stationary part of this. So those are just some high-level points.
That's gorgeous. David, wasn't I right when I said that they have great documentation? I know they already knew that, but aren't these docs beautiful with the videos and the pictures and equations and stuff? Like you're learning from them.
Yeah, even if you don't understand the equations, you can get a feel for what's going on in the math just because of the visualizations, which I think that's critical.
Yeah. So maybe we shift gears and start moving over into the roadmap discussion and use this as a jumping off point. I really want to talk about y'all's documentation. It seems like documentation is like a good measure of the health of a community. And I would say your community looks very healthy by your documentation. Yeah. Can you tell us a little bit about that and how you're able to interact with the community and how you use this to kind of build community, perhaps?
Certainly. So documentation has always been very important to us. And well, I think everyone understands how important it is, but nonetheless, it's often not the most exciting work. One thing that I think we benefited from is that people love to write blog posts about the cool models that they built. So a lot of these example notebooks that we have come from just notebooks and blog posts that people have done. And then when I find a cool one, I often would reach out to the author and be like, hey, this looks really great. Do you want to add this to the documentation of PyMC 3? So this is how a lot of this was built. By now, when people submit pull requests, and there's a lot of people submitting these pull requests from all kinds of different places, we have a requirement that, for example, if you say, okay, I want to open a new pull request, whatever. There is a checklist of what you need to do, and it includes documentation. So every new feature that gets included has to have an example and has to have documentation. So just by placing status on that is very important. But we're also lucky that because we have quite a few contributors from different people. So here I just noticed this Oriol Abril, who's a core contributor. He does a lot of work on this and is doing fixes on this. So we have quite a few people that enjoy doing documentation, and is very important. And it's a nice way to get visibility if you basically do something. So it's very easy for people to get started on and then transition to more deeper parts of the code base. Oh, and the last thing that I want to mention then is there's also all kinds of other materials. So if you go to books and videos, we have a discourse forum where people can ask questions. We have a conference, so we have PyMCCon, which will happen later this year, which I hope everyone will submit a talk to, and also attend. So I'm really excited about that. I'm just posting the link. So yeah, well, it's really about community. That's for us a really important thing, and I think part of why we have such a healthy community. And here, Chris, our benevolent dictator for life, is going to give the keynote, and we have 2 other ones which we're really excited about, which we're going to announce soon. And but yeah, and then what I actually wanted to show was that there's also a lot of work going on into either porting books of people who have already written books. So there's Bayesian Methods for Hackers, which was written for PyMC 2 and reported to PyMC 3. There's Statistical Rethinking, which is an excellent book, which was written for Stan, but reported to PyMC 3. Osvaldo wrote a book for PyMC 3, directly targeted on PyMC 3. There's all these resources, and then there's all kinds of talks on YouTube that you can watch. So yeah, we're just we're very active in this domain, and I think it is a big reason for the health of the community and the project.
This is fantastic. It's kind of inspirational, actually, just in terms of looking at how you've structured this and the material you produced. It gives you an idea of how to, if you wanted to build your own community and foster it, this is a great resource, in addition to just being a wonderful resource for the PyMC3 community.
Absolutely.
Well, super cool. Maybe we move along and we saw all the cool stuff y'all have. Where are y'all going now? So maybe you could tell us a little bit, some future directions, some places where you are looking for some more contributors, because PyMC seems like a healthy place to be contributing.
Yeah, definitely. So if you want to get started, we're excited to have you. One good place to start is to just look at the issues. We have different labels. So for example, we have a beginner-friendly label, and you can just look at what is there. This is like low-hanging fruit that's really helpful for the project, but is easy to do. But we're also always very eager to help people. One trick that I started doing, which is more successful than I thought it might be, a lot of people are writing issues where they're saying, oh, this doesn't work. And I'm like, oh, okay. Like the problem might be here and there. Do you want to do a pull request to fix that? And then like, oh yeah, sure, let me give that a try. So a lot of people were getting that way, but just basically being lazy ourselves and asking people to chip in. And I would say in like 80 to 90% of the people, percent of the cases, people are really excited to do so. So that's a great way. The direction that I'm most excited about is, one of them is, well, there's PyMC 4, which I want to talk to next. But before that, there's all kinds of different things going into PyMC 3 as well. So one thing, before I noticed that that we're building on Theano, right? Theano, as most people will probably be aware of, so the original authors stopped developing it, which is a bummer, because it really was a great package, and it sort of was the backend that we built PyMC 3 on. Now, this was one of the reasons why we started PyMC 4, but we also just realized that the existing user base we have is just huge, right? And PyMC 3 is really already such a mature package and does really almost everything we would want it to do. So what we've done is we forked Theano. So we are now maintaining Theano and are pushing it forward ourselves. So it's not dead. And one of the directions that we're pushing it forward on, which I'm incredibly excited about, is to make it use the JAX backend. So JAX is a new framework similar to, say, TensorFlow, but much more lightweight and better in many aspects, I would argue. and we can make Theano use JAX as the backend. And that way, we get access to all the modern technology there, and to things like GPU support or TPU support, and we don't have to worry about the C code that is in the Theano library. Instead, we can just use JAX, which does all these amazing compile time optimizations and everything, but still rely on Theano. So that way, we're actually solving all the problems. We still have Theano, which is, even today, I think, on par with all the other projects. And now we also are on modern infrastructure, basically, and don't have to rely on the Theano way of doing things that was amazing like 10 years ago, but now is a little bit old. A couple of other packages that I'm really excited about. One is Bambi. Osvaldo Martin, who wrote the book, is maintaining that. And it's basically allows you to specify all kinds of linear regression models as you would in R, so just with a single string. So it's very fast, and you can use hierarchical models. Another direction that is really promising is Adrian Sebald wrote Sun ODE, which is a wrapper for a ordinary differential equation library. And these ordinary differential equation models happen a lot in epidemiology, so they're very active today about, so these SRR models, all ODEs. And so this library just makes it extremely fast, and it's integrated with PyMC 3. So that is another great one.
That's cool. Hey, I gotta give you a choice here. We have a lot of questions from the folks in the book. Do you want to keep talking about the future, or do you want to answer the questions?
Let's go to questions then. The other thing that I want to make sure I notice and I mentioned is the thing that we're doing now, and that is so we are getting a lot of interest in PyMC 3 from all kinds of different companies. So over the last couple of weeks, I just had many discussions with people and who basically need help with that. And also with the other PyMC community developers, we always thought like, oh, how amazing would it be to work together? So now finally, it seems like the stars have aligned, and I'm really excited to announce PyMC Labs, which is a new consultancy that we are launching, and where we are helping companies to implement or improve their PyMC models and basically add this new way of doing statistics to solve analytical problems that are really difficult to solve any other way. So if you are, if you want to talk to us, send me an email. It's thomas.wiecki@gmail.com. I'd be more than excited to talk to you about that and work together with you. So that's my plug.
You keep telling us all these cool things. I can't figure out what the spoiler is. Was that the? Was that the?
That was the thing. That was the announcement.
That was the thing. All right. Well, now we know. PyMC 3 Labs. I'm excited for that.
Congratulations to you and everyone involved. That's exciting.
Thank you. Yeah, I'm really excited about it.
I can't wait for their training content, to be honest with you. I think that's going to be some good stuff. Well, how about we get to some questions from the audience? L. Lindsay was our first question. If you're familiar with Pomegranate, it's probabilistic modeling in Python, could you provide some insight in how PyMC is different, different use cases, different capabilities?
Yeah, absolutely. So Pomegranate, I think, is a package for mostly building discrete models. So it allows you to build, like, I hope I'm not completely mixing this up. Yeah, it's for mixture models or hidden Markov models. So we have discrete states. Pomegranate allows you to build these very flexible hidden Markov models. And PyMC 3 has a much bigger focus on continuous models. So if you want to build hidden Markov models, I would say this is a great way. PyMC 3 is focused on continuous models. However, we actually, this is another future direction, is Brandon Willard, who has done work that I mentioned in all kinds of different ways here already. He is working on contributing a new module for PyMC 3 that focuses on hidden Markov models and is really flexible and allows you to do that as well. So currently, with Markov models, you need Pomegranate or something different or something similar. but hopefully soon you'll be able to do that in PyMC 3 as well.
That's great. Let's see, there was another question from Emil Dimas. Can you give an interpretation of the standard deviation of the posterior? Thank you.
Yeah, so this is always a confusing concept where, well, we have a parameter, right, that tracks the standard deviation. Let's say we just have normally distributed data and we want to estimate the mean and the standard deviation. Well, you can do that in NumPy, right? You just compute mean and standard deviation, and that will give you two numbers. So that's fine. In the Bayesian framework, we are always working with posterior distributions. And these posterior distributions describe my uncertainty in the parameters themselves. So I have a posterior over the standard deviation of my data. And of that posterior distribution, I can also compute the standard deviation. So what that would reflect is the standard deviation of the standard deviation is my uncertainty in the standard deviation of that parameter. If I have very few data points, my uncertainty in the standard deviation of that, or in the standard deviation of my data will be very wide. If I have a lot of data, that will be very narrow. So that is what the standard deviation of that represents.
Well, that was a really good explanation of a hard question, I think.
Yeah, I agree.
So we have another question from L. Lindsay. Do you have any recommendations for tutorials, references outside the built-in tutorials or Bayesian methods for hackers to show real-world applications? For example, the RT Live example.
That's a good question. Yeah. So in terms of real-world applications, well, I would say that definitely the books on the website are pretty good, like Osvaldo's book. For actual industry applications, I don't really have a good answer. So that's definitely one thing that I'm trying to do with my course is like really have those of application models. There are definitely some in here that have real-world use case, like the stochastic volatility model that I showed, and the Gaussian process one, for example, the Mauna Loa one for CO2 levels. That is like a really good one. Yeah, so I would look at this page, but actually it's a good, I don't have a great answer to that.
Fernando Irazabal asks, do you know when you'll be releasing your course and approximately how much it'll cost?
So I hope that we'll be able to get it together by the end of the year. And on cost, I don't know yet. So that is currently what we're determining is really the length of the course. The thing that I'm now thinking is that it will be a shorter course. The first one will be very intro level focus, just really building intuitive understanding of the core concepts. So it'll be shorter, and then there will be another course for more applied and more advanced topics. So rather than one big thing, I'm now breaking it down into multiple smaller ones. And that way I can release it sooner at a lower price point per course. And yeah, I think it'll be more targeted. But thanks for your interest.
Great. Man, you seem like a good teacher. I want to take that course now.
Yeah.
So we got a question from David Brochart, which is, how has research advanced in quantifying uncertainties in deep learning inference? Are there applications embedding PyMC3 inside, say, TensorFlow, or the other way around, building a neural network inside of PyMC3?
Yeah, that's a great question. Definitely, that's a very active field of Bayesian deep learning, and there's a lot of really interesting things happening there. It's not really a focus of PyMC3. I have some blog posts that show how to do that, but there's other packages that are more focused on doing that. And I would say, for example, TensorFlow probability has some really strong examples in that domain, and so does Pyro. I would start looking there. and actually PyMC4 as well will support that. So because PyMC4 is built on TensorFlow and TensorFlow probability, it can use framework like Keras and whatnot. So the support there will be much stronger.
Amit Kushwaha asks, can you give an example or examples of how you've used this additional information about uncertainty to influence a business decision? And what are your thoughts around conveying uncertainty to management?
Yes, that is a really important question. And I fortunately just, I don't know, like 2 years ago maybe, found like the perfect answer. And it's Bayesian decision making. So the question is right on, right? So, and this basically is the story that I start with here is, well, you are a data scientist and your manager tells you to like build a model and you come back and you're all excited about the posterior distribution that you have. And he's like, what's a posterior distribution, right? So it's very difficult to communicate these ideas. But instead, what I'm arguing for in this blog post together with Robin Kumar, who is also doing really cool stuff, and you should follow on Twitter, is that you can use Bayesian decision-making to, instead of just providing a posterior distribution that will be the output of your model, is you use that posterior distribution in the optimization to solve the business problem directly. So you're not just saying, oh, like this is the output, now I'm done. You're saying, well, actually, what is the problem that I'm trying to solve with this? And here's the example of a supply chain optimization where we're trying to say how many items do we want to order from which supplier. And the idea and the joke is that this is around operating a spaceport, so it's a kind of futuristic vibe. And with that loss function, basically, the output is not just like the posterior distribution over which supplier is how reliable, right? But actually, we're taking this all the way and solving the problem to tell us directly how many we should order from every supplier. So at that point, right, the output is not a posterior distribution. The output is a decision that we're making. And that decision is not just based on the most likely case, right, but it's on all possible cases. So because we're using the posterior distributions, that uncertainty will be taken into account when we come up with that decision. So it's not the decision, that solves the most likely case, but is the decision that's going to be robust across all possible cases.
Well, super cool. How about we, thank you for going over just a little bit. I don't know if you've lost track of time, but we are over. So we're going to do one more question, and then we'll try and wrap it up. This question's from Abdul Rahman Uwewi. What are the key guidelines you will use to decide which tool set, Bayesian versus statistical models, when you solve a real-world problem?
Well, I would say that I view those as similar Bayesian and statistical problems in general. So I personally never use frequentist statistics just because I don't see a reason for that. But I mean, I would start with the one that where you find the syntax most approachable. So yeah, I would take a look at the standard syntax, take a look at the PyMC syntax, take a look at TensorFlow probability, and from there basically see what suits you best. If you're a Python user, I hope that PyMC3 agrees with you, but if not, there's PyStan as well. So these are all great packages, and it's really hard to pick among so many great options.
Well, that's great. Thank you so much. Now it's time for as we wind up, it's time for our world famous rant and rave section, where we just have 15 seconds to rant about whatever you want. And Thomas, it's your soapbox.
All right. I've been trying to use TensorFlow and find it really difficult to use. Whenever I want to do something, it's like there's 5 different ways of doing that, and I never know what the most recent one is. And if I use the wrong one, it's slow or it breaks. So I just found that to be a challenge. And we are facing that challenge too with PyMC 4, and that's why I'm so excited about JAX, which is, for me, much more lightweight and better alternative. So that is where I think the future is.
Awesome.
David, what are you ranting about today?
Today I've got a rave. Usually I'm good for a rant, but I just wanted to reinforce and say shout out to the Scrud team on OpenTeams, and that includes Abraham Maxfield, Daniel Alves, Igor Dirk, Ivan Ogasawara, Jacob Halcyon, and Tony Fast and Trent Oliphant. So thank you guys. I really appreciate the work.
Well, thank you for including me in the list. But I guess my rave is I love this open source directions so much because we use the word model and real world problems so many times together. If this was deep learning, machine learning, the real world problem thing doesn't matter. How do I model, right? But I love hearing the real world applications. It makes me want to explore this project a little more. So that's all we have time for today. Thank you so much for watching and listening. You can follow us on Twitter at QuantSightAI. And Thomas, where can people find you at? Really everywhere.
Yeah, so I'm on Twitter, Wiecki. I'm on LinkedIn. Connect with me there. And but yeah, Twitter is probably the best place to get in touch. But yeah, thanks everyone for tuning in. Thanks for having me on the show. It was a blast. Love being here.
Well, awesome. To our open source army out there, sign up for OpenTeams today to build your online profile and start keeping track of your contributions and get one of those good remote jobs going. Well, take care, everybody. Have a great day. Have a great weekend. And thank you all.
Thank you. Bye.